Hello and welcome to today's Windchill Automating CAD Validation webinar. My name is Ryan Gillott and I'm a CAD PLM data integration consultant for ITI, a Wipro company. I reside in the Harrisburg, Pennsylvania area. So let's talk about MBE value opportunities before we discuss validation. In a world where 3D model data is increasingly used to improve communication, not just in engineering, but across manufacturing and quality organizations, inclusive of the supply chain, so is the need for 3D CAD interoperability solutions. By enabling new digital technologies, as well as improving the ability for people to communicate and collaborate with each other, products are being developed and realized faster than ever before. 3D CAD neutral file formats such as STEP AP242 and your traditional STEP files, as well as the new introduction of the Quality Information Framework Standards, or QIF, they're being introduced into quality organizations to do what STEP files and 3D CAD files did for manufacturing and CNC programming for decades, to now automate in metrology and quality applications. Digitizing these processes creates a digital thread and improves the ability for people involved to communicate with each other using formats such as 3D PDFs, as well as the machine readability and automating data persistence across that digital thread results in a significant reduction in errors and nonconformances. All of this digital thread and model-based enterprise, all these concepts require the reuse of a solid, accurate 3D annotated model. Without this model, or without trust in this model, there's going to be people across the enterprise that reject this new way of doing things and resort to their old way of doing things. There's the age-old saying, if it isn't broke, don't fix it. So we need to make sure we're building trust in this 3D data, not only the master data, but also the derivative data that is used throughout the digital thread. So if you're going to rely on the model, you must have a reliable model. So let's talk about the three primary validation scenarios. The first one is derivative validation. This includes exact geometry neutral file formats used for machine consumption, such as CNC programming or CMM programming in the quality world, as well as 3D interactive viewable formats such as 3D PDF. While the uses of these file types differ across the enterprise, the need to validate both is the same nonetheless. The next type of validation scenario is 3D model-based checking. This is the process of checking a model against a set of rules, an individual model. We're not comparing the native Creo model to any derivatives, but we're checking that native Creo model's quality. That could be geometry rules. For instance, here we have a thin solid volume. That could be important, whether if it's a plastic injection molded part, that may be a very difficult area to fill in the molding process, or if it's a machine part, it may be an area of concern where you're going to create a very weak spot where during the machining operation we could actually cause a failure in that area of the part. In addition, 3D model-based checking, if you are doing or working actively engaging in model-based definition efforts, we can check the annotations or the PMI against any of the international standards, the ASME Y14.5 standard or the ISO GPS standards. So it does give you that checking ability to make sure that the annotations are defined correctly, make sure they're associated to geometry. If the desire is to reuse this downstream to automate metrology applications or even CNC and manufacturing applications. So 3D model-based quality checking is still a very powerful scenario. The last one is 3D model revision compare. I once had an engineer tell me that you can't get rid of his drawings because when he had to review an engineering change. He would create a D or E size print of Rev A and then another one of Rev B, put them next to each other, and compare the two one line element at a time and one letter at a time. Very tedious, time-consuming process, but very thorough. Right? Without those drawings, we need a solution to be able to compare two different models. In fact, I would actually argue, and I'm going to discuss in a slide, in the next slide, or maybe 2 slides, additional use cases or scenarios for the compare capability. So why automate validation, right? If you're new to validation, or if you've been doing it for years, it's typically been performed in a desktop environment, and the process looks like this. Right? First, we're going to have to search for the models in Windchill. We want to do a compare of Rev A to Rev B. We then export that file to disk. So we've immediately, right off the start, created some risk. Right? It's in an uncontrolled environment. Second, we're running the software on a local workstation. So we now have to manage we have the overhead of managing those software installs, upgrades, troubleshooting them on every workstation where validation is going to be performed. We also have to manually manage reports. Right? We're going to generate either a native CADIQ viewer reports, or we're going to create 3D PDF reports that can be viewed in Adobe Reader. Just like the uncontrolled environment of exporting the files to disk, we have the same issue with manually managed created reports. Right? Sure, we can upload those reports and attach them to the objects or the EPM docs, as they're called in Windchill. But what if we upload those to the wrong version? So there is a manual process that is error prone, and it's rather time consuming. So all of these, while we get the results that we want out of our validation, the throughput is going to be very low, and it is still somewhat error prone. So let's pivot here and talk about data integrity in the digital thread. Right? A part design typically starts with a model that defines the part to be realized. It could just be, if you're not working on model-based definition, it could just be the geometry. If you are working in a model-based environment, it could include the geometry and the annotations. From there, we're going to generate derivatives, and these derivatives are meant for downstream consumption. Even sometimes within upstream, if we're doing simulations such as FEA, we could be using a derivative to feed into that simulation tool. Right? So those derivatives are going to have the exact geometry, or it could be lightweight geometry for any number of reasons or consumption scenarios downstream. 3DIVs are 3D interactive viewables. 3D PDFs are a good example. Creo View is a good example of an interactive viewable, and those are used for people to collaborate. So this is where we get into the people consumption and improving that communication between the people. We're even seeing a trend to move to more web-based collaborative environments. Windchill visualization, where Creo View is used in a Windchill environment. Your HTML5 and WebGL enabled viewers and collaboration tools. Those are making a pretty big impact in the market. And so at some point, our design is going to become mature enough to send down to manufacturing. Right now, we've spent years, decades, trying to maintain that associative integrity by using Creo functions like merge features, inheritance features, so that when that product model is updated, the changes ripple across the enterprise downstream to your manufacturing models. If you're using Creo NC into your NC programs, and so on and so forth. I think at this point in time, we all can recognize that at certain point times is a futile effort. It could be going to a supply chain that is using a different CAD tool. if for no other reason, the people in manufacturing don't trust the product model, and they turn around and create a model using the drawing of the product model as reference, right? Doesn't really make sense, but it happens. And there's many other reasons why models are recreated. So I think once we can accept that reality, we at least need the ability to quantify or identify the differences between these models downstream and the product model, and perhaps even the differences between different models in manufacturing. Right? We could be creating models that represent a part after a manufacturing operation 1 and one after 2, 3, and 4. Right? Those things are being done. They could be driving manufacturing simulation tools, but there's still a need and value in identifying the differences between all of those models. Right. From there, we're also going to generate derivatives. Our manufacturing technology may not support native Creo files, so we may need to create exact step file derivatives for that. We may also be creating manufacturing work instructions that leverage the 3D interactive viewable technology. From there, we're going to feed the manufacturing definition as well as the product definition models into quality. Quality is quickly becoming a model-based organization as well, leveraging 3D technologies, leveraging 3D standards such as QIF to generate bills of characteristics, automatically populate first article inspection forms, CMM programming, so on and so forth. It's happening, and it's happening fast. Right? So they have their own derivatives. Right? I mentioned a few of them there. CMM programs, could be quality fixtures, etc. They could also create their own 3D interactive viewables to help quality personnel do their jobs better. Because again, it's model-based definition isn't just about machine readability in the digital thread, it's also about improved means of communication amongst the people. Right. So with all of this 3D data being generated across that digital thread, and we already conceded that we're going to break some of that associativity that Creo offers, but for one reason or another we can't take advantage of it. So we're going to need the ability to validate through compare. We could be doing quality validation, we could be doing derivative validation, not just from product definition, but throughout the entire enterprise. Once we get there, a desktop validation solution just is not going to cut it. It's not going to give us the volume that we need, and it's going to be too error prone. So eventually we're going to get to a point where we need to plug this into a more automated environment. So let's talk about Windchill CADIQ finally. We're at Windchill CADIQ 3.1. And if you look at the different capabilities, it really supports all of the same capabilities as the desktop solution. Same validation scenarios, same types of reports, same types of model analysis, same file formats, and it currently is supported on Windchill 11 and Windchill 12. One of the best things that I like about Windchill CADIQ is it can be plugged into your existing workflows. You could have existing promotion workflows, existing engineering change workflows that can leverage Windchill CADIQ. It does not use the traditional Windchill CAD worker environment that we all love to use, and can be kind of challenging at times. So it is leveraging different Windchill technology than the traditional CAD worker environment. Right. Windchill can, we also, because we're not using the traditional CAD worker environment, we're not going to really leverage the WVS job monitors. We have actually built our own CADIQ job monitor. So it works the same. We still are going to be able to see all of the jobs that are being funneled through the system and see where their status is, and also use it to identify failures and help troubleshoot those failures. So let's talk about running CADIQ interactively. So not only can it be plugged into your existing workflows, it can be run interactively. So the first thing, even if you're going to plug it into your workflows, the first thing that needs to be done is to set the job template. Right? We can leverage the job templates that we generated over the past few years, or if you're new, in the desktop environment. Right? So we can build those libraries of checks. It could be a standard precision, high precision. Maybe we just want to check or evaluate geometry, geometry plus annotations. So we're leveraging all the existing capabilities of the desktop CADIQ just in a Windchill environment. Right. By setting that job template, it's also going to populate a CADIQ template parameter. Right. So that's just to identify which template that this particular object is going to leverage once a CADIQ job is initiated. There's also some additional attributes here that are assigned to the Creo model, as well as your Windchill object attributes. And that's your CADIQ check results, validate result, and compare result. Right? So these are the three different scenarios, validation scenarios. Right? We can set it up to be a pass-fail for check, pass-fail for validate, compare, is it the same or did it change? Right, and oftentimes we may need to introduce a dispositioning type of process in there, because if anybody's working has been doing validation or working with validation for a while, you understand how difficult it is at times to create or identify just simple pass, fail, or binary logic. Sometimes a person may need to get involved in the process to review the results and disposition any failures or diagnostic errors. Okay. So once you've set the job template, you can now initiate any of the different CADIQ validation scenarios. Right. If we initiate a CADIQ check, you're going to be presented with a confirmation, right? Because once you hit OK, it's going to now send this to Windchill CADIQ. And it does require that the object to be checked in. Right? It can be invoked from your workspace information page or your common space information page. It just does require the object to be checked in. You will receive an email confirming the initiation of this request. So once the job is complete, you'll get an email with the results. Right? Due to size of the attachments, as well as security concerns, you can configure it to include the attachments or exclude them. The attachments include a native CADIQ viewer file, as well as a text summary report, and the 3D PDF report that we also can create from the desktop solution. In addition to the ability to attach them to an email, they will be saved as attachments right within the CAD object in Windchill. So once they're added as attachments, you can see to the right of them there is a download. So the viewing isn't going to happen right within the context of Windchill. A consumer would need to download those, and if they're, for instance, downloading the IQJZ file, that's the result CADIQ viewer results file, they're going to require the CADIQ thick client viewer to be installed on their workstation. A text file can be opened in any text editor, and the PDF report can be downloaded and viewed with on any workstation that has Adobe Reader installed on it. Okay, so for derivative validation, the first step is to create a derivative. So you can create a derivative right from Creo by save a copy, you can generate a step file, and you can use the option to save the new file to the CAD's document. Right? Oftentimes you may not be using Creo to generate your derivatives. You may also be using a third-party solution to generate those derivatives. Those derivatives can be uploaded and attached to the document right from the Windchill PDM link interface. So regardless of how you're generating the derivatives and attaching them to the object, they are going to be stored as attachments right within the Windchill objects information page. And you can generate more than one derivative. So when I get to the next step here, I'm going to validate. I got to initiate the validate first, and once I initiate it, it's going to prompt me for the derivative or derivatives. Right? I can validate and select multiple derivatives here. Perhaps I have a step file derivative as well as a 3D PDF derivative. I can select both of those and validate both. Right? As with the check job template, the validate job will send you an email notifying you that that validate routine has been initiated. And then for our third scenario is the compare. Right, similar workflow, only rather than searching and being limited to attachments, we actually have the ability to search our Windchill database for any object. Right, it could be an older revision of the same object, or it could be a completely different file. It could be one of those manufacturing files. Maybe it's a mold design reference model that I want to see the difference between the final part and the model that has had shrinkage and warpage applied to it. And so we can select any existing object in Windchill. So once we've done that, we click OK, and then it's going to follow the same process. We'll get the email with the notification that the job has started, and then we'll also get the email with the attachments if you have it configured, or the attachments or the attachments will be stored with the object in Windchill. So that's a quick summary of the Windchill CADIQ capabilities. I hope you found that interesting and useful. I'm going to pivot now to something we're working on that's coming soon, which is a WebGL results viewer. Right? So the results currently can only be viewed in the CADIQ Thick Client Viewer or the Adobe PDF reports, but there's really not much that you can do there as far as collaborating on those results. So I'm going to actually toggle here to a set of results. Right? Here we have a WebGL set of results. It's going to look and behave very similar to the native CADIQ viewer. Right? I can look at the results by, let me turn the dispositioning off. Right? I can search the results by view, and I didn't mean to have the dispositioning turned on, but now I'm going to turn it on. Right? And here we have the ability to disposition these different defects. We can look at all of the different contexts, which are your different saved views, or as we know are combination states in Creo, or we can look at them individually. So here I'm going to look at that narrow solid spaces diagnostic. Right? And maybe as a designer, I don't really know what to do with this one. Right? So I'm going to right click and move to a new disposition item. And from down here, I can then type in review this narrow solid space. And then, once this gets plugged into a web environment, somebody else, could be a manufacturing engineer or a supplier, could come in and add a comment. This is not going to be a problem, and save that, and now we've collaborated on that diagnostic in a WebGL environment. Right? So again, this is a new capability that's going to be introduced soon. And you would end up repeating that same process, going through all of your diagnostics until you actually have dispositioned all of them. So that concludes the webinar for today. I hope you enjoyed it. If you have any questions, please feel free to contact me at the email listed here.